Good morning, students. In this lecture, we are going to design a gated latch circuit with the two input G and D and one output. Right. Now you consider gated latch. Right. Gated latch here. The latch is if you are applying that gate, then only it allow that one the data whatever the data is as out. Right. So here now you are having now this is gate applied and at the same time the data is 0. Now the output is 0. This is one case, right? So t is q, t whatever the t value, that is q, right? If gate is applied means a clock is applied, right? Gate is open, then the data is stored in q. Gate is open, the data is stored in q, right? If you are having the data is 1 and the gate open, then the data is going to be stored. These two are regular, right? These two are regular, you know that one, right? So that one is you got right. 0, apply gate 1, then it will 0. 1, apply gate 1, it will 0, right? Then thereafter you consider now applying the gate 0. Then here you have to consider if the input is 0, applying gate 0, then it may be 0, or applying gate 0, it may be 1. Then similarly, here gate 0, you are applying 1, then it may be, there is no change, right? If it may be 0, it may be 1. So you have to consider these four cases, right? So here, if you are having now that 0, 0, 0, then when it is 0, here already the previous state is 0. So that is here state after A and D, right? So here, if A is a state where the output is 0. After that, if you are applying 0, 0, then this is 0. Or otherwise, in the D, here we are having now 1, 0, that output is 0. So A and D. So A after D, now if you are applying that 0, 0, right, then you will get now 1. Here, if you are applying 0, 0, you will get now 0. If you 0, 0 applying, you will get now 1 when already we are having that state 1, right? So that is after B, this is the state 1, this is state 1. So after BD, after PF, right? So here we are having now after, so this is output, this is output, right? So that is here, this is these two cases, right? So after P and after F. So this is here. B, this is B is 1 and F is 1. So this is retain 1. Even you are applying that you are applying 1, but gate is 0. It's, already existing one, right? So that is state after P or F. After P or F. Here after A or D. Because here we are having 0. So the another zeros are A, D. So A or D, then it will have the 0. Here in the D, here we are having now, this is D, then this is after C, right? So that is C is, we are having now 0, 0. Then it is 0, already 0. Then if you are applying 1, 0, it will go for 0 after C. Right? Now, these are all the possible total state of gated latch. So you have to be understand that this A B C D E F, right? Now, this A B C D E F is going to be draw primitive table. Primitive table. How do you draw the primitive table? Is here we are having that input is DG. So you can write the all possible value in the gray code 0, 0, 0, 1, 1, 1, 1, 0. Then you consider the total states A, B, C, D, E, F. So for each one, you have to give the name. So these are all the possible states, possible state and output. These are the possible state output. Then what is the situation? So you have to write now, right? Now, here, how do you fill that primitive table? Primitive table, right? Then here, how do you fill the table, right? So that is A. So A is actually 0, 1. So in that 0, 1, you fill that one A with circle, right? So that is stable state. The output is 0. Stable state. So you put that circle. So from the state A, if the input is 0, 1, then it will go to the A state itself. So this is the case, right? A itself and output is 0. Similarly, here B, the input is 1, 1. So 1, 1 is here, right? So input is 1, 1. In that input 1, 1, you have to put B and the output is 1. Similarly, for C, the C is 0, 0. Here C is 0, 0. Then here you have to fill that one C with circle and the output is 0. For the 0, the output is 0. For C, the output is 0. So you have to put now the output is 0. Similarly for D, D is 1, 0. So in that 1, 0, you have to fill this table D and put the output, corresponding output. Similarly for E also, you put that one. E is here 1, 0. So you have to put that 1, 0, you put E and the output is 1. So you put it here, come output. Right? Then F, then here F, for that F you are having 0, 0. The state is 0, 0. So you put now the after 0, 0, you put F and put circle 1, right? So wherever you are putting the circle is a stable state, right? Now you have to fill that other parts. How do you fill it? Right. Now we are going to fill that this one, right? So here, how do you fill that one? A 0, 1, 0, 1, then this is the output A. Then it will, after that one, if you are having now that 0, 0, then it will reach C after A, right? So that is here, after A. After A, if you are having 0, 0, it will go to 0. The output is 0, right? Then here in that 0, 0, you put now that status C, right? The status C is 0, 1, right? So status 0, 0. Then here we don't know, we don't care, or we don't know that what may be the output. So that is you put now C, right? So you are having now these cases, you put now dash. Similarly here 1, 1. So that 1, 1, after that 0, 1, then it is going to have that 1, 1. It will be B. So here you put now B, right? And you put dash, right? So here only that you output you write, then all others are you don't care. That one, right? Then B, right? Next one is after A that 1, 0. After A 1, 0, right? So here we are having 0, 1, 0, 1, then we are having only one bit change at a time. So 1, 0 is 2-bit change. This 2-bit change is not allowed. So that is here you put now that one not allowed, then that is put now the whatever it may be, the dash dash. So whatever the state and whatever the output. So we don't bother, don't care. Next, similarly for B. So B 1, 1. So from that 1, 1, then there is no possibility of 0, 0. So that is here you put now dash dash. Then from 1, 1 to 1, 1, 1 to 1 already, right? So 1, 1 to 0, 1. 1, 1 is 1. Then if you are applying that 0, 1, then it will go for the result is 1, 1, 0, 1. Right? So 0, 1 is the state is A. 0, 1 is state A. Don't worry about that one, right? So here 1, 0, the 1, 0 is then after B, that is E. After B, and F. So that is here you put now E and dash. Similarly, here E, then if you are having the 0, 1, then it will, from 0, 0 to 0, 1, it will reach that A, 0, 1. So output is 0, so that is reaching now. So that is here, you put now, you put dash now, right? So this is 0, 0 to 1, 1 is not possible. So you put now dash dash. So double changes is not allowed. So double changes means 0, 0 to 1, 1. It's not possible. So C is 0, 0. So 0, 0, 2, the 1, 1 transition, then you put now the dash, dash. Then 0, 0 to 1, 0. So 0, 0 is output is 0. Now we are applying that 1, 0. Then 0, 0, 1, 0. Then it will reach to 0. Then you are putting now D here after C. After C. So for the D, you put now D, right? Then similarly here for C, then it will go for C. Then here that C, D is, we are having now, D is 1, 0. Then 0, 1 is not, right? Then here you have to fill now is. Now, from that, like that, you have to fill now all states. Then from that one, then you have to find out the grouping, right? So A, B, C is same group. How it is that A, B, C is same group? Here you see this one. C. Here don't care C. So this three are A, B, A, C, D, A, C, D, right? So this A, C, D, right? Then the C is same. C, 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 right? Then output is don't care. So that is here. Output here don't care. Here 0. So here you can merge that ACD. ACD is merged, then output is, you can put it now 0. ACD, the output is 0. Then here we are having now ACD, similarly BEF, BEEF. So that also we can merge. So that is here for that each and every row, we are having that and dash dash and some here D. Right. So D and tone car. Tone car, whatever you can have the same, right? So next here E dash. So this three E dash, right? B E so E E. So these three can be merged. P C, right? So that is P E F. Then if you are merging, then here we are merging ACD. ACD is merged because ACD is somewhat similar state. So then ACD is merged and you give the reference. So so you are merging C comma 0. Then this is A comma 0. Then this is B comma dash. Then here we are having now. Then this is D comma 0. D comma 0. Right. So everything is dash. So you put now dash here. Right. Similarly, here also you have to join, right? Now you have to give the representative, A as representative for ACD. So the C is replaces A. So then this is A. Then D also replaces A. Then similarly, PCF, you have to take that B as representative. So wherever that F and E, the PEF, right? PEF is merged together and you take representative as B. So wherever EF, you replace that one by B. So this is the case. Right? Then you have to give now for A1, B0. So A is output is 0 and B equal to 1. A equal to 0, B equal to 1. So then you are replacing the digits 0, 0. Then here the corresponding one that output is 0, 0. Then A is 0. Then here B is 0, B is 1 and A is 0, B is 1. Now this is the diagram for excitation variable. And then here the output 0 1 0. Then here we are you take now that dash, that you take it as 1. Then here also, here we are having now, this is B, right? So here we are having now the B. Then here we are having bottom is 1. Then you put now that one as 0, right? So we are having now, then here you have to consider now this is the output map. Then you write the equation, right? So this is everything is four ones are grouped together. So for that you are giving name as y. So q equal to y. Right? Here we are having now this pair and this pair. So for this pair, what is that value now? This is dg, this component. And for this pair, these two pair, then we are having now the common is y and g dash. This is the g dash. G dash, Y and G dash. right? Then using that to map, then you have to draw the circuit. So this is circuit, right? So that is here D and G. So DG and right. Then here G dash and Y. This is G dash Y. Then this is the case as Y, right? So now this Y is this one, right? This Y is feedback to the small y. So we are getting now, this is the gated latch diagram. Gated latch diagram. Suppose they may ask about then how to design a gated latch diagram. Then you have to represent the total state. You have to represent the total state. You have to represent the total state. From the total state, you have to try a primitive table. Then the primitive table is converted into this is a this is a float. This is a primitive table, and you have to go for the float table. Here we have to reduce the table, then we can grouping together and we reduce the table. After reduction, then you have to give the binary number for the corresponding one. For A you are giving 0, for B we are giving 1. Then you have to fill that one for getting the feedback path, for getting the output, right? So in that feedback path we are having now using Karnaugh map. You reduce that one, you will get now this is the expression. Then that expression is realized by the circuit. So TG G dash Y. So G dash here Y is the feedback and then G dash Y. So this is the Y out, right? Then output is Q equal to Y. So that is Q. Output is from Y. You are taking now the Q equal to Y. Y Q equal to Y. Then this group together and we are getting now Y. So Q equal to Y. So that Y is directly connected with as output Q. That's all. We will continue by another lecture.